Hey everyone, welcome back. In this particular lecture, we're going to be going over the basics of argumentation, what an argument is, and how we translate our arguments into the scientific method. We do that through the framework of hypothesis testing. So we're going to go over what an argument is, and we're going to go over the general terminology for understanding and developing hypotheses. The argument process, right? An argument is just an expectation that you have about a phenomena that you're wanting to study or these processes in the world. Most of the times it's based on not only your gut inclinations, but also the extant or existing research and the literature that you've read, right? So as you're developing your research question, you're doing a lot of digging and reading, and it helps you create and formulate these expectations about these other phenomena that you're wanting to study. So your argument is an expectation based on the existing research or literature and your understandings of these phenomena at this point. But it's one of the most difficult parts of the research process, in part by the fact that it's tentative. When you're first making this argument, you don't know whether or not it's correct, right? It needs to be tested. So you're making an argument based on your best guesses and understandings of a phenomena, but you don't know whether it's correct. Even after the point that you've created your research design and you've undertaken the testing phase and you've done your analysis, you still often don't have full proof of that theory or that argument, in part because it takes many studies to prove a theory to be true. In addition to the fact that we talked about some of these data constraints that we have on whether or not we're operating in this causal environment. So we may only have associations or some evidence of a relationship, but not a causal bit of evidence about the relationship. So the argument process is one of the most difficult things to wrap your heads around, but I want you guys to think about arguments being expectations that you have about phenomena based on the existing research and literature and your gut understandings of things as researchers. So in order to translate these arguments into the scientific method, we use hypotheses and these framework of certain kinds of hypotheses. So arguments are complicated. So we're going to translate them into something that's more simple, which are certain kinds of expectation statements that we can then test. So hypotheses and a hypothesis is a theory-driven statement, right? So a statement that we have driven by our understandings of the broader theory and the research that states the expectations about the relationships and concepts in your research question. So it's an set of expectations about those causal concepts in your research question. So what does that look like in practice? We're going to go back to this framework of understanding political knowledge and political behavior or voting, right? So we had that really broad understanding of, well, I'd like to understand voter indifference and why people don't go out to vote, maybe why they're apathetic. So we've made that more specific, right? We talked about specifically, we want to understand voter indifference through the framework of whether or not they voted, right? So this political behavior component, and whether or not they had certain kinds of political knowledge, more or less political knowledge, right? So you first, at the most basic level, need to make a declarative statement about the expectation. So what that would look like in the example is there is a relationship between political knowledge and party ID. That's a declarative statement about the expectation of the relationship. It is non-directional though, because it doesn't say anything in depth about what that relationship looks like. It's a non-directional hypothesis. That's at the most basic level. You're making a declarative statement about the expectation. A keyword there is a relationship, right? Not any more descriptive than that, but we just say that there is a relationship between political knowledge and party ID. Oh, so we're using party ID instead in this particular case and not political behavior. So when we talk about party ID, we're talking about partisanship. Right. So I think party ID is actually the working example in this one. And party ID essentially just means whether or not you identify with maybe the Democratic Party or the Republican Party. So we're saying there is a relationship between political knowledge and party ID. That's a non-directional hypothesis that clearly states the expectation between the two different concepts. To go a little bit deeper, a more specific argument that we can make that this is the kind of area I want you guys to push into is we're making a statement about how the cause affects the outcome. So giving more description about how X causes Y. This is a directional hypothesis because it tells us how the cause and effect are related. An example of this would be as someone's political knowledge increases, so they know more about the Supreme Court and our institutions and Congress, they're more likely to be a Democrat. I'm not making any sort of normative statement about whether or not that's true, but that is a directional hypothesis saying that as political knowledge increases, they're more likely to be a Democrat. So it links our independent variable, which we'll talk about a little bit more soon, our X with our Y, which is the ultimate outcome. And the keywords that you want to look for the directional hypotheses are that something is increasing or decreasing, right? So anything that sort of makes sort of a directional claim, those are the kind of keywords that hone you into the fact that it's a directional hypothesis. Non-directional is just going to say, make a blanket statement that there is going to be a relationship and not going to go deeper. Things to keep in mind, these hypotheses, again, should be a good reflection of the existing body of literature. We're not we ideally don't want to just replicate existing or settled work that already has been done. In addition to the fact that being very well read also makes you have more confidence in your theories and your arguments. So essentially, keeping that in mind when you're building your hypothesis, it still should be couched in this framework of building good research, which is being well read and understanding what gap your research will be filling. Hypotheses should be very brief and concise. You shouldn't have huge, long hypotheses. If you do, maybe break them out into separate hypotheses, or you can make sub-hypotheses. But they should be very honed in as well, and they need to be testable or operationalizable. I shouldn't pick political knowledge and party ID if I don't have access to variables that study that, or if I don't have the money to conduct a study that would ask on those particular things. I'm choosing these things because I know I can test those. So keywords from the slide I want you guys to think about is this idea of a non-directional versus directional hypothesis, thinking about the way that those statements are framed so you can identify, okay, this is a directional, this is a non-directional hypothesis. And I want you guys to think about how creating your hypotheses is related to the broader structure of making an argument to build evidence for theory that you're trying to test. There are additional terminologies I need you guys to understand in order to translate, particularly this hypothesis testing framework, into this idea of statistical learning or using statistical tools to garner evidence from your data and see patterns. And this is the kind of null and alternative or working hypothesis framework. The hypotheses that we went over in the previous slide, we can call those our working or alternative hypotheses. That's really where the meat of our argument is coming from, right? So our working or alternative hypotheses, I'll probably use that language interchangeably. More often than not, I'll probably say alternative because that's the standard language, but either of those work. They show exactly what our expectations are. So there is a relationship between political knowledge and party ID. That's a really great example of a working or alternative hypothesis. The null hypothesis, which is what we're kind of going against or looking to reject in statistical learning frameworks, is what would happen if our expectation or argument did not exist. So the null hypothesis for part one is there is no relationship between political knowledge and party ID. The working hypothesis is there is a relationship. The null hypothesis, there's no relationship. And the null hypothesis would look really similar for part two. Instead of as somebody's political knowledge increasing, they're more likely to be a Democrat. It would just be that political knowledge is not related to being a Democrat. So the null hypothesis framework, as I said, is absolutely crucial for understanding statistical testing and statistical modeling. And so we'll return to this as soon as we start to get in these frameworks of t-test, chi-squared, and regression. We'll be able to kind of understand it in the context a little bit more clearly and why you guys need to know null and working hypothesis. So just to kind of rehash this example, as someone's political knowledge increases, they are more likely to be a Democrat. This is our alternative. If we wanted to test this in the actual framework, if our evidence supports the alternative or working hypothesis, we can reject the null. So the way the framework and language we always use is rejecting the null. which means that we do have evidence for our working hypothesis. The alternative to that is saying we tentatively accept the working hypothesis, but I want you guys to get in the habit of saying we're rejecting the null. If we have some evidence, say we have a statistically significant result in our regression, that language will make more sense to you later. We'll say we reject the null hypothesis that there is no relationship. So if we have evidence, we're rejecting the null because the null is the case when there isn't a relationship. If there is no evidence that we garner from our study, we say that we accept the null hypothesis and reject our working. But really, we want to get in this framework of accepting or rejecting the null. That's just kind of the conventional language. So we're going to end here on this sort of hypothesis framework, and we're going to move on to talking a little bit more in depth about the role of argumentation.